We hear a lot about stem cells these days. But what are they? Where do they come from? And what do we really know about them? Inside our bodies, there's a microscopic world, busy and complex like the world around us. Stem cells build and maintain this world. This is a story of stem cells and their lives inside and outside our bodies. Life begins with one cell, the fertilized egg. Throughout development, cells divide over and over again to produce the billions of cells that make up the body. At certain stages, most cells stop making copies of themselves and start to specialize. When we are fully formed, almost all of our cells are specialized.
Cells are very beautiful things when you see them down the microscope. Normally they're so minuscule we can't see them, even though they're what make us all. And each type of cell has its own characteristic. Some types of cell grow together, very closely together, and form beautiful patterns. Other types of cell will move away from one another. Some cells become big, other cells are always very small. It depends on what type of cell they are.
These different cell types work in specialized teams. Some carry oxygen through the blood system. Some do the stretching and contracting in our muscles. Some carry messages between our brain and the rest of our body.
Stem cells are very special cells, and they act as a reservoir, really, because the specialized cells can no longer make copies of themselves. So if they die and get used up, then they have to be replaced from somewhere, and this is where the stem cells function. Stem cells are used in the blood system. We need to make millions of new blood cells every single day, and these are generated from stem cells. And these cells actually live in the bone marrow. Altogether, the blood stem cell can make 8 different types of specialized cell. They're used in the skin. We need to make new skin cells all the time because we're always wearing away our skin. And actually now we know they're present even in the brain. We always have to make new stem cells so that they're not completely exhausted, because otherwise we'd lose the capacity to make any new cells at all. So the stem cell has to make a decision. Every time it divides, it produces 2 daughter cells, and those daughter cells can be new stem cells, or they can be specialized cells. Stem cells in the adult tissues can normally only make the type of cell in that tissue. So a stem cell in the skin can make cells of the skin, but it can't make blood cells, and vice versa.
Stem cells are already useful in medicine. One skin stem cell alone can produce enough specialized skin cells to cover the whole body. This produced a breakthrough in the treatment of extensive burns. Stem cells are also used to treat patients with blood disorders, such as leukemia. A transplant of just a few blood stem cells is enough to repair the entire blood system. Stem cells for specific tissues and organs can only make the cells of that tissue. We know there are stem cells in skin, blood, guts and muscles, but we don't know whether other organs have their own stem cells, or how useful they will be. Back along the chain of development, there's another kind of stem cell. It's controversial. It can become any specialised cell, the embryonic stem cell. This cell comes from a blastocyst, the stage of development before implantation in the uterus. For fertility treatment, blastocysts are produced in the laboratory. If they are not used for a pregnancy, they can be donated for research.
In the early embryo, there's a group of cells that can give rise to all the tissues of the body. These cells are the ones we're very, very interested in, because we know that we can take the cells from the early embryo and grow them in culture and maintain them in a state where they can contribute to all the tissues. What we're seeing here is the blastocyst stage of development. It's smaller than a pinhead, actually. You can't see it without the microscope. So basically at this stage, the cells in the embryo, these are the cells here, they can make any tissue at all. What we have to do is isolate these cells. One way is we can remove the trophectoderm cells so that we're just left with a clean inner cell mass. So we can grow these in culture and they'll grow, multiply until we have large numbers of these cells that still have the capacity, are still able to form any tissue at all.
Embryonic stem cells can become heart, blood, brain or skin cells depending on the way they are grown. These stem cells have turned into heart cells,